Very good morning. I welcome you all for next lecture series. In this series, we are going to discuss addressing modes of 8051. In last class, we have discussed about the pin diagram, so which consists of 40 pins. Each pins are assigned for some functions. Some pins are assigned for two functions. So we are discussed in detail. So today's class, we are going to discuss about addressing modes. So addressing modes of 8051, there are 6 type of addressing modes are there. So first one is immediate addressing mode, second one is register addressing mode, and third one is direct addressing mode, and register indirect addressing mode, and then indexed addressing mode and implied addressing mode. We have to see one by one with example. So first one is immediate addressing mode. So immediate addressing mode, the operand which follows the opcode is a constant data of either 8 or 16 bits, and constant data to be stored in the memory immediately follows the opcode. The constant value to be stored and specified in the instructions itself rather than taking from the register. So the destination register to which the constant data must be copied should be the same size as the operand mentioned in the instructions. So the example, move a comma hash 0 30h. Here the accumulator is loaded in with 30. The hash represents the immediate addressing. So immediately the 30 data should be moved to the accumulator, which is called as the immediate addressing mode. And then next one is register addressing mode. So register addressing mode, the data transfer from represent through the registers. So in 8051, 4 banks of working registers with 8 registers in each bank. So each bank consists of R0 to R7 and a specified operand in the instructions. And it is important to select the appropriate bank with the help of PSW, that is program status word. So example of register addressing mode is move a comma R5. So here the 8-bit content of the register R5 of bank 0 is moved to the accumulator. Whatever the data it has, it consists of R5 is moved to the accumulator. That we called as the register addressing mode. And then next one is direct addressing mode. In direct addressing mode, the address of the data is specified as the operand in the instructions. Access any register or on-chip variable. So include general purpose RAM, SFR and IO ports, control registers are mentioned through the direct addressing mode. Example of direct addressing modes are move a comma 47, which means the RAM location 47 is moved to the accumulator. So register indirect addressing mode. The address of the operand is specified as the content of register. Example, move a at R1. The at symbol indicate the addressing mode as the indirect. So if the content of R1 is 56H, for example, then the operand of internal RAM location is 56H. If the content of RAM location 56 is 24H, then 24H is moved into the accumulator. And only R0 and R1 are allowed in indirect addressing mode. These registers are called the pointer registers. And then next one is indexed addressing mode. The effective address of the operand is the sum of base registers and an offset register. The base registers can be either a data pointer or a program counter, while the offset register is the accumulator. Only move C and jump instructions can be used. Useful when retrieving the data from lookup tables. So example for this index registering is move C A at A plus data pointer. So here the address of the data pointer is sum of the content of the data pointer and accumulator. And then implied addressing mode. So implied addressing mode, there will be the single operand work on specified registers only, also known as the register specific resistance instructions. And for example, for this implied addressing mode is RLA, that is rotate left accumulator and swap. These are 1-byte instructions. The first one is used to rotate the accumulator content to the left, and the second one is swap the nibble of the accumulator. So these are the addressing modes of 8051. So if you all have any doubt, you please ask. See you in the next class. Thank you all.